Notice the roller coaster problem from the last video. The interesting places, the extreme values, the minimums and the maximums. So we have this one absolute minimum, which is at the lowest point on the roller coaster. And then all the other minimums and maximums that occur, relative minimums, relative maximums, and then this absolute maximum here, look at where they occur. They occur at places along the function where if you were going to draw the tangent line would be horizontal. The tangent line here, horizontal. If you look back up at this picture, the local minimums, local maximums, they happened here. Tangent is horizontal. Here, the tangent is horizontal. Here, there's another place where I have this local maximum. The tangent line wouldn't be horizontal. The tangent would have isn't defined because I have a derivative from the left that's positive, a derivative from the right that's negative. So here, interesting, I just don't happen to have the derivative is undefined. So this leads us to this big, exciting theorem. This theorem doesn't have a name, but it saves us a lot of work. It's one of the biggest ideas in first semester calculus. If a function has a relative extreme value, a local minimum or a local maximum, a top of a hill or a bottom of a valley, somewhere in the interior, so not at an endpoint, because remember we're gonna not have controversy and ask about local extreme values at endpoints. But if a function has a local minimum or a local maximum, and the derivative happens to exist at that place, then the derivative must equal 0. So this is a big deal because now we're going to spend most of the rest of semester 1 finding extreme values of functions. That's our goal for the next 3 or 4 or 5 weeks. When we're asked to report about extreme values of functions, we don't have to look at every single x value. We know we can limit our search to endpoints, local extreme values, which means only we're going to have to look at places where the derivative is equal to 0, or places where the derivative is undefined. So now we only have 3 categories of points where we have to look. So this leads us to this definition. A point on a function, an x value on a function, is called a critical value if, there we go, f prime of x equals 0. So a point, a value x, is a critical point of f if f prime of x is equal to 0, or if f prime of x is undefined. So important definition. We're going to practice finding critical points next.